Hello guys, welcome to Blender for computational design, and today we're gonna be doing the second video of chapter 2, which we're gonna talk a little bit about faces, how to declare a face inside Squarechuck, and a couple other tools inside Squarechuck to create faces for us. And this should give us the basis to be able to create our custom geometry inside, like basic geometries inside Squarechuck. So let's get started. The first thing is go to Squarechuck in your node editor, and we're going to start a new node tree. Shift A. Um, so first, I'm going to actually explain before this. Let's explain what we're going to be doing. So I deleted the default cube, and let me get the grease pencil. So what we've been doing so far is that when you have a face, or sorry, when you have a geometry, we've been doing vertices, and then what we do is we store each vertex as an x, y, and z, right? As a tuple with 3 values. And then what we do is, so first we have a list of vertices, and then we have a second list which which specify the edges. And the way we specify the edge is by giving it two vertices. So in this case, 0 and 1 will create this edge, right? And then if we want to create the next edge, 1, 2, we create this. So if we keep going like that, we'll end up doing the whole the whole square, right? Um, and then one thing that is important is the face itself. So how do we define a face, not just the edge? Is that it's actually the easiest one because we declare just the vertices that we want to use. In this case, 0, 1, 2, 3. This is going to be one face, and then we could have more faces if needed. But right now we're just going to deal with one. So let's see how this actually looks in Squarechuck data. So Shift A, generator, plane. Then I'm gonna grab Shift A, text, note, and here you can see our list of vertices, right? And then our list of edges, 0, 2, 1, 3, blah, blah, blah. Of course, the order is gonna be different because you can actually define how you're gonna create edges, how you're gonna create faces, and that's completely dependent on the person who's programming or what algorithm you're using, or if you want a specific way for it to be done. It can all be done. So this is why it's interesting to, instead of using this plane, which is very useful, but maybe you want to do something different. And now after watching this video, hopefully you can define your own shapes inside Squarechuck and create the vertices, edges, and polygons. So I'm gonna delete this now that we know how it looks like in Squarechuck data. And let me finish erasing this. All right. So Shift A. Let's start with the nodes or script, scripted node light, and Shift A, base viewer draw. All right. So let's get started. The first thing we're gonna do is we're gonna have our directive. You remember it's 3 parentheses that we're gonna start with, and then we're gonna declare our input sockets. So input size on X, type S, then the default value, which can be anything we want. In this case, we're gonna use 1, and the nestedness value. How deep do we want to look into this list to get that integer value or that float value? Then again, we copy this and we do it for Y. Same values. Oh, no, this is one, and this is what I'm going to change. Same nestedness. And then we need our output. So out, we can call it in this case vertices, right? and type actually B. We close our directive. Now, when we created this out, for us, it created this list. I don't know if you recall that from the last videos, but now what I need to do is populate it. So I want this to spit out through the output socket a list of vertices like we've been doing before. So our B0 can be in tuple 0, 0, 0. Then if we copy this and we add this, now what we need to do is we created different vertices. They're all in the same location right now. We'll deal with that in a second. But now what we're gonna do is actually I need to append them to our vertices list. So vertices dot append and then b1, b0, right? So b1, b2, and b3. And now I can copy this again and paste it 4 times. Now this is not the optimal way to do this. There's of course better ways, but I think this is the easiest way to explain this part of the video. So feel free to try it differently. You know, if you want to do a for loop here, you know, feel free to do it. That's fine. All right. We plug in the text. We can actually rename it to polygon.py. And we select our file here in the script node. We connect it. We put it here. And if you recall before, something we've been doing is I usually go to Sverchuk, 3 UI options, and I activate the socket menu to grab it. And that way I can actually see my vertices. They're all in the same spot, so it looks like it's only one. We're gonna change that in a bit. But another alternative to using this grab and this socket menu, now something important is that if you want to do different things with the data structure, here it allows you to change it, this output socket. So just keep that in mind. You can test what it does, each one. But for now, what I'm gonna do is I'm gonna actually deactivate it. So no wrapping. I'm gonna turn off the socket menu, and let's say we wanna do everything from here. So the easiest way to do this will be vertices. Not the easiest way, maybe there's other ways, but this is the way I like it. It's very visual, so for the tutorial, I think it's gonna make sense. So I put vertices equals a list, and what I'm gonna put inside this list, my old list. So what I'm doing is I'm making a new list that contains my list of vertices, and that way what I did is I created another level in my list. So once I run it without wrapping it, I now have my my vertices here. Now here what we can do is, if again if we look at this, let's say we're gonna work on the C plane. So the first one I wanted 0, 0, 0. The second one I wanted to move on my size X. So you know, it's going to be the bottom right corner. So I'm moving an X, SX. Then the second one, Y will stay 0 and set 0. Now the third one, sorry, would be SX, SY, and 0. So it's going to be in the top right corner. And finally, on the left top corner, I want to put SY. So 0, comma, whatever, comma 0 for Z. So let's see if this works, and there you go. We have our 4 vertices. Now, what we've been doing in order to make our what we've been doing to make our come to automate our edges and faces. If you can program that, you can make an algorithm inside your script to do it, which is a good practice if it's something simple, or if you understand what you're doing, or you have a special way to do. In a bit, we're gonna see some options we have. If you only have vertices, how can you create faces from them without having to code yourself the data structure for the edge or for the face, right? But in this case, we're gonna actually go ahead and do it manually. So once I have this, what I can do is I'll start a for loop for vertex in vertices, vertices for vertex in vertices. Actually, I'm doing this wrong for b in length. So vertices. I put this line because I'm not sure if I have to deduct one later. So let's see what happens. So for vertex inland vertices, uh, for no, for b in range. Sorry, for vertex in the range in the length. So what I'm doing here is that I'm counting the numbers, the number of elements with this function. I'm counting how many items I have here, which is 4, and then I'm creating a list of 0 to 4. I could keep this for b in vertices. I think that will also work, but then this gives me a little bit of if later on I want to rest one or add one to close a loop or something. This sometimes is been working for me in certain cases. In this case, I don't think it matters, but we're gonna keep it like this. So our first element of the edge is gonna equal our current number, and our second element, we already did this before, so I'm going a little bit faster, be plus 1. And then what we're gonna do is edges dot append. And what are we appending? Our tuple of edges, which is e1 comma e2. There you go. So again, we have e1 e2 e1 e2 depending on where we're in the loop. It's gonna 0 the first time 0 comma 1, 1 comma 2, 2 comma 3, 3 comma 4, or whatever, depending how many items we have again. But okay, we did that, and now same thing. This is gonna create our edges, and then edges, we're gonna use the same strategy, equals a list with the edges list inside it. And now hopefully, oh, first I actually need to do the out edges. Let's see if this worked, and boop, it did work. So we got our square, and our square rectangle seems to be parametric, so that's good. And now to create a face, all we gotta do is create a new list, out faces b. So our list is gonna be faces dot append, and what I'm gonna append here is gonna be b, right? Now I'm gonna put this b, actually I'm just gonna put it like this, append b. And again, we have faces append b. I'm gonna run it like this, and what happens now when I plug in this here is that we're getting an error, right? And this error comes because right now, if you look at our, again, let me grab the text note here. If you look at the data we're getting here, it looks fine. We're getting a list with the numbers, but then let's look back at what we were getting from the plain one. And if you see, it's inside two lists. So what we gotta do here is faces equals, and what I'm gonna do is I'm gonna put two lists, and inside those two lists, I'm gonna put my faces, and there we go. We created our first face. Now this is really basic, but I did want it to, not this one. I did want it to show you how to create a simple face. Now what we're gonna do is we're gonna turn this into a polygon that we can actually change how many sides we want. But if you like it, you can go ahead and try different things. For example, how would you do it if you want it in the middle, or if you want to change anything from it, like the origin, right? I don't want it to start here. I want it to start somewhere else in the 3D world. Then you can also do that by adding some um, input sockets. All right, so let's do this, and what we're gonna do is first we're gonna think a little bit of what we're trying to achieve, and I'm gonna disappear this for a minute. And what we're gonna do now is we're gonna use a function. So in order to draw like a polygon or like an end polygon, an n-gon, is we're gonna put our first, if this is our center, we're gonna put our first vertex here, right? We're gonna start like here, and then we're gonna divide like a circle. So depending on how many edges we want, how many vertices we want, we're gonna divide this circle into those edges. So if we want a four-sided polygon, we're gonna end up with, again, a square. But now if we want 5, then we will be dividing this circle into 5, right? And if you remember, this a full circle is equal to 2 pi, right? So the circumference is 2 pi, and half a circle is going to be equal to pi. So we're going to use this value to divide it by the sides that we want. So let's do that right now. And what I'm going to delete right now, it's this part here. I'm going to keep this here. This is our kind of our final process to kind of make our data structure the way we want it. But here is the actual algorithms we're using to create the geometry itself. So I'm going to delete that. I'm going to start with a for loop for, I don't know, I in range. And then what's going to be our range is going to be our sides. So for each side, what I want to do is create 3 values, x, y, and z, right? So I'll correct this in a minute, but I want to explain something in the meantime. And then from here, we can create a point, or, yeah, so let's see, our point or edge, or, our vertex is going to be p equals our tuple x comma y. Well, I did a list this time, but I don't really think it matters if you use a tuple or a list here. And I'm going to change my input here to be a size, default the1, that's fine, and then e size and sides. So we're going to have a size and sides for now. So range divided by sides, there we go, looks good. Now I'm going to append these to my vertices, vertices dot append my p, right? And now every time we create a new point, it's gonna be added to our vertices list every time we loop into this list. And the first thing I want to show you is, again, I mentioned in the previous video, we're going to be using a methodology from Joseph Coma in his book Morphing, which I recommend, because we're going to be using a lot of the maths in this book to create our geometry in these next steps and in future videos too. So what we're going to do is actually first we're going to import math. So this is how you use a Python library from within Sparkchuck. So math dot send, and then what we want to do is, as we were talking before, is we're gonna take p math dot pi. I think this is gonna give us back the value of pi I don't know how many decimals it's gonna give us, but it's gonna be very, very, very close, very precise. So math of pi times 2, and then we're gonna divide this by our sides. And the reason I'm doing this, again, I'm gonna delete this, is because, again, with this math dot pi divided by 2 is half a circle, and what I'm doing is getting a full circle, right? So 360 degrees divided by sides. So I'm dividing 360 degrees, dividing by the number of sides. In this case, if we want the default to be 3, it will give us whatever value it is that I don't remember right now, but we'll get that. But then we need to do something to change it, because the first time we loop, it's gonna get here, right? We're gonna get this difference, right? So our first vertex is gonna be here, and then the second time we want it here, and the third time we want it here, and we want it to keep rotating around. So in order to do this, I'm gonna multiply this by our I. That way, every time we have an iteration, it's gonna consider the past times that we iterated over it in order to get the full circle. So sides times I think this should work. Vertices dot append p. Let's see if this worked. And what's happening here? Okay, boop. So we're getting something there. We're getting 3. And if I increase the size, we're getting more. It's a line. But if you remember, in order to have a circle, right now we're creating a line. Here, for example, I can have, I think it's I perhaps. What happens then? Yeah, we're gonna get a sinusoidal line. And we join the edges, we'll get this. We'll deal with that missing extra edge we have later. But if you look at it, what we're doing now is graphing this sine wave again that we did before. But if you want to make a circle here, what you gotta do is, instead of using sine, you gotta use cosine to kind of, so same formula, but with cosine on y. Now, there you go. So we have a circle. And well, we have a circle, but it's actually an n-gon because we actually can change the sides, and we can have sided, four-sided, five-sided n-gon depending on what we need. Now we're having an error here. If you see, it's coming back. I think if we actually visualize the, I think index is what we want to see. So if we visualize this index here, actually edges, sorry about the type is different. This here I had type wrong. Apparently it did work, but still. But I don't like that color. I need a completely opposite color. All right, so 0, 1, 2, 3, and at the end is going back to 0. So what's happening here? Again, usually what I suggest is go to text and try to understand what is happening here. So edges. So we have 0, 1, 1, 2, 2, 3, and then 3, 4. But there's no 4, so that's the problem we're having. So what we can do now here, when we created this, we can actually subtract 1 here. We'll finish this, but 1, 2, 3. We gotta do a last one to join these two, right? To join these two together. So in order to do that, what we can do is, let me just check my notes here, just so I get it right the first time. So we're gonna put an if statement, yep, and if b is less than the length of the vertices, minus 1, then I want to do this, right? Else, if that means when we get to the last one, when we get to the last now this works if you want to have an open polygon, right? And actually the face should be working right now. Oh, right now it's getting broken there. Oh yeah, because we only have 3, so we're missing to add the last one. So we need to take this out actually. And now, oh, not that one. All right. So right now it's doing the same, but I actually put it down here. And what I'm gonna do is else. I want to do this same thing exactly, but with a tiny difference. Instead of appending it to the e to be plus 1, I'm gonna append it with 0. And that way we closed our polygon. So again, let me erase all this stuff. All right, so we're back here. And yep, so we're getting this complete polygon. We can actually change the size of it. Oh no, the size is not changing yet. We'll do that in a second. And the sides, so we can increase the number of sides. And every time we're getting its face and its edges, no matter what it is. Now we're gonna talk about the first transformation, and the first transformation it's called scaling. And scaling, it's as easy as just multiplying times our size. So we're gonna take this factor size and we're gonna multiply it our whole formula. Actually, what we can do to keep this more kind of organized and more visually, this is probably not, it works the way it is because it's already up. The order of operations will have happened correctly, but still I wanna do it because so you understand that I'm taking this whole block here and I'm yes, this whole block here, and I'm multiplying this whole block by the size to apply a transformation to the whole thing. So now every time I change my size, it's gonna be increasing or scaling or scaling down. We could actually scale down if we actually change this to be a sorry about that. There you go. So now we have a float value, so we can actually scale it down. All right, guys. So this is the first one. I hope you understood how to make a face, the basic kind of um, data structure to create the edges, and the basic data structure to create the face. And in the next video, we're gonna do some grids. So after dealing with grids and some cool things with grids, we're gonna move into surfaces. Thank you guys, and see you next time.